In this section, we're going to talk about the electromagnetic spectrum and the waves that make it up. Hello Scouts, in this section we're going to discuss the electromagnetic wave. Most of what we will talk about is to give you a background in this science. You will not be required to know all of this, but it is difficult to explain things if one is not familiar with the terms and some of the words which radio operators use. In this case, the thing we want to classify is electromagnetic waves. And in order to do that, we need to know just a little bit about an electromagnetic wave, for this is what a radio wave is. The word spectrum is used to classify something in terms of a position on a scale between two extreme or opposite points. You will find that the electromagnetic wave includes gamma rays, X-rays, infrared light, visible light, and radio waves. It took scientists a few hundred years to realize this. An electromagnetic wave is made up of two energy components that travel together. One part is an electrical field, and the other is a magnetic field. Thus it gets its name of an electromagnetic wave. Now, a little bit about waves. Waves in physics are a repeating pattern or cycle. Waves are described by the use of math. The length of a complete pattern is called a wavelength. The number of cycles occurring in a second is called frequency. We use the second as the basis of time for calculation, and the number of cycles in a second is referred to as hertz. So we have three new terms: wavelength, frequency, and hertz. To make an electromagnetic wave, you need only to move a charge. This could be a current in an antenna, a spark, a lightning bolt, a spark plug, an electron in an atom. Making them do what you want is the hard part. Here we have a sketch of an electromagnetic wave. You can see the length of the wavelength or repeating cycle length. We also see the electric field E, and at right angles to the E field is the magnetic field labeled B. This is a common label used by physicists. In this example, we also see an oscillating charge. In practice, this charge could be an electron spinning around an atom, or perhaps it is moving back and forth in an antenna. Whether we talk about an X-ray or a radio wave, we can describe the wave by the use of this type of an example. Now here's an interesting fact about electromagnetic waves. They all travel at the same speed, 300 times 10 to the 6 meters per second. The actual number is 299.79 times 10 to the 6 meters per second, but 300 is close enough for our work. You may recognize this as the speed of light. If we take the wavelength in meters times the frequency in megahertz, we get 300 meters per second. The formula for this is written at lambda times f equals 300 meters per second. We can describe a wave either by its frequency or its wavelength, since if we define one, we've specified the other. These abbreviations are used in describing radio waves. Instead of saying a million hertz, we can say megahertz or kilohertz. We also use abbreviations such as M and K when we write these down on paper. There are several other abbreviations that describe very small waves, such as gamma rays and X-rays. For our purposes, these abbreviations are what you should know. Now, one thing I didn't talk about much was the relationship of electromagnetic wave and energy. I'm sure many of you have a microwave oven at home, and if you put a hot dog in that oven or a cup of coffee and you turn it on, it's going to get hot. It literally will burn material if it stays in there long enough. The shorter the wavelength, the more energy an electromagnetic wave has. And as we get smaller and smaller and smaller, we're looking at things like X-rays and gamma rays, which can literally knock electrons from material. So when you deal with electromagnetic wave, you must be careful with them. and you must understand the energy that they contain. Radio waves, like microwaves, can burn also. So this is an aspect that you want to think about when you're dealing with an electromagnetic wave. Okay, in front of you is a little chart. Well, this chart is compressed a little bit, and what it's showing is the position on the spectrum where radio waves fall. These are measured in hertz, kilohertz, megahertz, and one I didn't mention, gigahertz, which is a little bit larger than megahertz, to describe where these radio waves fall. The wavelength is measured in meters, and for very short wavelengths you would use centimeters, but we radio operators don't normally use that. A doctor might for x-rays. So this is where we're going, and you're starting to get an idea, because we're going to want you to know where the different radio bands fall within this electromagnetic spectrum. Radio operators have found it convenient to classify radio waves in the spectrum in the following order: very low frequency, 3 to 30 kilohertz, low frequency, 30 to 300 kilohertz, medium frequency, 300 to 3000 kilohertz, high frequency shortwave, 3 to 30 megahertz, very high frequency, 30 to 300 megahertz, ultra high frequency, 300 to 3000 megahertz, super high frequency, 3 to 30 gigahertz, extremely high frequency above 30 gigahertz. There are hams that are experimenting in the gigahertz range. This is a relatively new area of experimentation, and it does cost a little bit of money, but there are guys that are actually talking in the microwave frequency area. Now, so what frequencies are assigned to whom? Federal Communication Commission decides that. And if we look at this chart, they said that AM broadcast radio will be at 540 to 1600 kilohertz. FM broadcast radio can go from 88 to 108 megahertz. Shortwave broadcast 5 to 22 megahertz. Television broadcast channel 2 is 54 to 60 megahertz. And CB radio is 27 megahertz. Police radio is 450 to 470 megahertz. Now you can talk on the CB radio at 27 megahertz with a CB radio you can buy at a truck stop, but you better not be talking on the 450 and 470 megahertz with the police radio. Amateur radio is assigned 3, 7, 14, 21, 28, 50, and 144 megahertz. 80, 40, 20, 15, 10, 6, and 2 meters. Notice the change in describing the wavelength versus a frequency. Either one is valid. So this is the reason that we want you to understand what electromagnetic wave is and what a spectrum is. Now we get to the workbook questions. The workbook is going to require that you draw a sketch of the electromagnetic spectrum for 4 of the classifications: medium frequency, high frequency, very high frequency, and ultra high frequency. Then on these charts you will locate at least 8 radio service stations, 4 amateur radio bands, and the police and fire bands. I'll show you how to do that in the next few slides. As part of your requirements, you will need to answer in your workbook questions about the electromagnetic spectrum. They will ask you to draw a scale from 100 kilohertz to 1000 megahertz. Then you'll fill in the sections or bands for medium frequency, high frequency, very high frequency, ultra high frequency. They will also ask you to put in the microwave band. If you put the 1000 megahertz marker at the end of the scale, you will have no room for the microwave band. 1000 megahertz equals 1 gigahertz. The ultra-high frequency band ends at 3 gigahertz. Microwaves are above 3 gigahertz. So to solve this problem, make your scale a little longer than the 1000 megahertz. Do not get confused by the terms kilohertz, megahertz, gigahertz. You will also be asked to draw the medium frequency, high frequency, very high frequency, and ultra high frequency sections. You are to identify at least 8 radio bands and the police band. These bands are assigned by the FCC, so if you use a radio, it is your responsibility to know what frequencies they must operate on. In these next 3 examples, you will get an idea of how to fill out your workbook. This is an example of the high frequency section. In it, I've put the 80 meter band, the 20 meter band, shortwave, 10 meter amateur band. These are approximate locations of where you will find the operating frequencies. This is the very high frequency section. This includes the FM broadcast band and the aviation band. There are others, but this is an example for you to use. And here we have the ultra high frequency section. I've included the police between 450 megahertz and actually 470, I believe. And there's a section for cell phones. Again, there are others in this band, but these are an example. Okay, we're just about done here. So now we got to go to your workbook. Page 3, question 3, and you fill in the answers to the questions about the electromagnetic spectrum. It should be fairly easy now. Good luck.